Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps for the world's best companies as quickly as possible. So, continuing our examination of the Hub App project template, we're going to learn how the hub page.zaml and the item page.zaml binds to the data model that we learned about in the previous lesson. So binding is also known as data binding. It's common in the programming world, especially in the Microsoft platforms and tools and so forth. It's a convenient way of tying the presentation layer to the data model of your application. So you can declaratively define the data source, most likely a collection of objects for a given control, say a grid or a list, and then tell the control to bind to the data source and the particulars of how you want things displayed. And then it takes care of creating a visual representation of each item in the data source as a row or as a list item or whatever the case might be. So whenever you're building phone apps in Zaml, you use the binding syntax that we learned about previously. We saw how to bind a static resource for the purpose of styling. We've looked at it a number of times. Let me just point out that, for example, here's an instance of binding to a static resource for the purpose of templating as well. So we'll use a similar style syntax, but use a binding expression that looks a little bit more like this here, and there will be variations on it. And we'll talk about some of the most popular variations at the end of this lesson. So let's start at the very top and then work our way down. So the page class, in this case the hub page class, defines a private field called default view model. So if we take a look at the code behind the partial class hub page, we can see that there is a private field called default view model that's set to a new instance of observable dictionary. We'll come back to that in just a moment. This class is something that the template developers added to the template. It's not part of the phone API, so you can see its definition, if you wish, here in the common folder. You can see that there's this observable dictionary class. It's not all important to understand how it works under the hood right now. All I really care about is what its name implies. Now, we haven't talked about the word observable just yet, but we will pretty soon. So for now, just focus on the fact that we're working with a dictionary, observable dictionary. And so recall from the C# Fundamentals for Absolute Beginner series that a dictionary is a specialized collection that allows you to create a key and an associated value. If you think back to that series, we kind of likened it to Webster's dictionary, where you have a key, the word that you want the definition of, and then you have the actual object or the definition of that key term, which would be in Webster's dictionary the definition. And in this case, we're dealing with something that has, for example, a string as the key and then an object that is related to that string somehow. All right. So this will be important in just a moment. I'm going to go ahead and shut this down for the moment. So back to our hubpage.zaml.cs file. If we were to scroll down and take a look at our load state, and you recall from the previous discussion about the navigation helper, that this load state is a method that our class handles because it's raised by the navigation helper. At the point when our page has been navigated to, we call on navigated to, it does some things related to state management and then calls back into our load state method here on our hubpage.zaml.cs file. All right, and you can see that it has two lines of code. Sample data groups equals sample data source dot get group async. We looked at that previously when we were looking at the data model, the sample data source .cs file. And then once we get the collection of groups that are returned to us from this get groups async, then we set that to a key called groups in our default model, which is an observable dictionary, and then give it all those groups that were returned back from the getGroupAsync method call. So this code adds a new key called groups and then sets the associated object to an instance of this collection of groups that's returned from our getGroupAsync method, right? At this point, this is the only thing that gets loaded into our default view model. This is the only entry in our dictionary. So imagine Webster's dictionary only having one word and one definition. And so you might wonder to yourself, well, why did they go to all this trouble to create this observable dictionary class just to hold one item? This one collection of groups. Wouldn't it make sense if they had multiples? Well, again, I would remind you that this is a template. You could add more things to the dictionary if you're expanding this example for your own purposes. Then you can pull out what you need in the binding expression in Zaml, like we'll look at in just a moment. But you can only set the data context for the page to one object. So you would use this dictionary as a container for all of the data that you need to load into the page itself. Okay, everything that you need to bind to from the Zaml. So again, this case, maybe it doesn't fully flex the muscles of the observable dictionary, but still you're going to need a container, one object, and that will serve as the default view model that we bind to for the rest of the Zaml page. And so it might as well be something that's flexible enough for future use, because again, that's the intent of the template, to be used by you to flesh it out and use for your own content, not just this silly little example. Okay, so now let's go here to the hubpage.zaml file and take a look at the page's declaration. Specifically, take a look at the data context property of the page. It's set to binding default view model. Where does this get this default view model from? Well, you can see that the source, the relative source, is self. So basically, look in my own class definition to find an instance or a property called default view model and use that as the context of data, where the data comes from, the data context for everything you see on this entire page. All right. So again, that is where we call into this read-only property default view model, which will be loaded up with all the groups and all the associated items into this entry, this key called groups. All right. So a data context is defined by a parent, like the page, which owns everything else inside of it, like the grid, the hub sections, and so on. So the data context is defined by a parent, and then it's utilized by its children. So in this example, the parent is the page class, and the children are the various controls that will take the data from the default view model and bind to it. So given that the data context for the page is set to the default view model property of the page, the observable dictionary that was already full of data, now we can revisit the Zaml that we looked at a couple of lessons ago. So let's take a look at hub section number 2 here, and let's interpret that in light of the fact that we now understand what we're binding to, what the data source is, or the context for the entire page. All right, so we see here that we're binding to, in the hub section, or I'm sorry, in the hub section, we're binding to group. So it's setting its own data context for all of its children to specifically a property of the default view model called groups. And not just any groups, but groups sub 0. And what this means is that we want to work with the groups key, but since sample data groups is bringing back a whole collection of groups as defined in our sample data source, through this whole process of loading multiple groups and then associated items, we want to grab the first element, or if we look at our sample data, this first group and its associated items, all right, as it comes out of the file. So that's what we're binding to with this expression. We're binding essentially to this first group and all of its associated items. All right, so that's the use of this sub-0. Okay, now that we're binding to that group, that single group, it has an items property, right? So since the data context for all of the hub section's children, including the grid view, is that one group, we would expect them to be able to bind to a specific property of that group being items. All right, and then for all the individual item or sample data item objects, we're going to look inside of the item template for the remainder of the binding syntax. So we're setting the context for this item template to the items property of a single group. So back up here to page.resources. And so a single item in the items collection will have, let's take a look at our sample data source one more time and look at all the properties that are defined. Unique ID, title, subtitle, description, image path, and content. All right. So here we're going to bind to the image path as the source of the image. That makes sense. And we'll bind to the title as the text property for the text block. And that, my friends, is what gives us the data to select one of the images from our assets folder and then the text that we see here. So, for example, item 1 will have a title of item title :1, and its image path will be set to assets/light gray. Obviously, there's some other properties here we're not utilizing, but that's essentially how we're getting from the very top, where we're binding to the context default view model, all the way down, and the context flows down from the top of the page to each individual item in each individual item of type sample data item, then here in our image and our text block. So just in case you don't see the correlation, I illustrated this with a diagram. Hopefully this will help. On the left-hand column you have data, and on the right-hand column you have the Zaml. And you can see how the data flows down from the default view model to the individual properties of the sample data item, and then how that corresponds with the Zaml. At the top you have the page, and its data context is set to the default view model, and then how it correlates all the way down to the individual image and text block controls with their given properties that are being bound to image path and title respectively. Okay, so just a couple of takeaways from this first example. First of all, keep in mind that the data context keeps flowing downward. In other words, the page's data context flows into the hub section, and the hub section's data context flows into the grid view, and so on until we get to the bottom, which is where we actually display the given properties of one item. So understanding the hierarchy in binding will allow you to keep things straight in your own mind. The second thing that I want to take away from this first example is that when you're first getting started, it's useful to stay close to the examples like the ones in this template. If you can merely modify the existing example until you're more comfortable with the hierarchy of controls and settings, you're going to be more productive right away. So you're going to see how I'm able to utilize this hub app project template and especially this data structure. Like I said, we're going to create that entire Cupcake app here in just a few lessons. So I'm going to make a few small changes to these templates, to the data structure, to the data, and then to the Zaml that represents it. And I'm going to be able to create a whole new app using different data, but essentially the same kind of hierarchy, making tiny changes. All right, so let's take a look at a couple more examples. I want to back up now to hub section 1, since I kind of glossed over that. So here's the, first of all, the Zaml that binds to the groups. So again, at the very topmost level, let me bind all this up, we have the default view model, and the default view model has a key called groups. So our hub section 1 will bind to all of the groups, which makes sense because when we look at section 1, it just has the group titles. So we're working with groups, not items at this level. Now, we said that the data context flows down. So here in the list view, we're going to list all the titles for the groups. Therefore, we're going to bind to the groups that are set as the data context for the hub section. So in this case, you can see that we're not binding to something else. The binding is going to flow directly from hub section groups down to the item source for the list view, which is also binding to groups. And then for a specific item in the group, so the item template, a specific group item or group object, we're going to bind to its title, and I think that's it. We're just binding to title there in a text block, which you can see here. Okay? So the big differences that we're going to see as we compare this hub section 1 versus hub section 2 is that in hub section 1 you can see that we used a list view instead of a grid view like we used in hub section 2. In hub section 1, each individual item is styled in the body of the data template. So we didn't require, for example, to go up to page.resources and define a data template here. Why not? Well, because in our particular case, we didn't need to reuse, let's see, here we go. We didn't need to reuse this data template for other hub sections, so we just went ahead and defined it right here in line. All right? And then the third thing that differentiates what we did in section 1 versus section 2 is that here we see in the item source, it's just using this binding to pull the entire flow. It doesn't refine the data context from the hub section. It says, hey, you're already binding to a list of groups. That's exactly what I need to bind to right here in order to display each title, the title of each group. Whereas in hub section 2, we're refining the data context down to a specific group. Within a given specific group, we're refining it down to a specific property of that group. And then further, as we get into the item template, getting to the individual properties of an individual item. All right, so that's the fundamental difference. So the rest of the hub sections use similar techniques to the two that we've looked at, and I'll let you take a look at those on your own. Hopefully you'll be able to decipher them based on this discussion. But there is one last thing, one last curiosity that I want to kind of look at here, and that is this data. As I move my mouse cursor from hub section to hub section, you can see that in the designer, I'm able to get real data. In fact, if we compared this data to the data that we find in the sampledata.json file, it's identical. It's pulling that data. The question is, how is it pulling that data? And the way that it's doing that, let me move this back over and go up here to the top. There are actually several namespace declarations and then this d:\data context. Now, in the past, I've gone into long explanations about what all this means. But essentially, whenever you see this d: in Zaml, or especially in phone apps, that prefix should spark in your mind the thought of design time only. So what we're doing here is creating a design time data context versus a runtime data context. The design time data context is ignorable at runtime. So that's the purpose of these two namespaces. They look up the rules for a design time experience, and that design time experience should be ignored at runtime. So this d:\data context is set to, now we're binding and we're setting a source attribute equal to design data, and then where are we pulling the actual values from? Ah, yes, the data model / sample data.json, and so on. And so therefore, that's how we're able to get this data. It's utilized by Visual Studio and by Blend in order to give us this rich design time experience. Why do we need a design time experience that displays data visually at all? Do we need this? Well, we don't need it per se. If you're creating your own app, you could skip that step. However, it's convenient whenever you use the Visual Studio Designer to preview what the content will look like whenever it's properly styled. So just know this: if you change from the sample data.json file and use some other technique or some other data source for your app, you might get weird results at design time. You just won't see any data, or you might get some error that's displayed on the designer that it can't bind to that data. And so at that point, you have a decision to make. Are you going to supply fake data and essentially re-implement this sample data.json file so that you get a rich design time experience, or are you going to ignore that altogether and just keep running the app every time you want to see one small tweak or change that you've made to the layout of your data in your data templates? All right. So before we conclude our examination of binding, and data contexts and data sources and things like that, let's move on to the item page.zaml. And let's take a look specifically at its code behind the item page.zaml.cs. And you'll see that it shares a lot of the same sorts of features as the hub page we just looked at. For example, here's a private field called default view model. It is of type observable dictionary as well. There is a public getter for this public property called default view model. If we take a look in the load state, here we are retrieving the navigation parameter that's sent to us by the navigation helper class as an argument into the load state method, and then we're calling that get item async from our sample data source to retrieve a single item, and then we're binding to that item with a single key called item, setting it equal to the actual object that we're pulling from get item async. All right, and then in the item page.zaml, let's move this over a little bit, we can see that we're setting our data context to the default view model dot item. So here we're saying go ahead right off the bat and just give us the dot item. In other words, give us the only item that we would expect to see inside of our dictionary called item. And where do we find that? Well, we find it in the same class where we're working in right now. In other words, item page, because it's defined in the class item page here. These are two parts of a whole of they're partial implementations of this single class item page, right? Moving on, if we scroll down then to our stack panel, which is this little title panel here at the very top, the only thing we're really binding to right now is the title property of the single item that we pulled back into our default view model with the key item that we pulled from get item async. All right, hopefully by moving and traversing that back and forth, you can see the relationship and how that works. All right. Obviously, taking a look at this, and you can even see there's a little to-do item. Content should be placed within the following grid to show details for the current item. They just didn't bother to do that. We could take the time and flesh that out if we really wanted to, and we will whenever we build a full app. But the intent here is to merely provide the framework that you would use to add more detail to this page. So the most important aspect of this is the binding syntax. In this case, we were able to navigate at the page level to the single key called item set to a sample data item, and then bind to the individual properties of that sample data item. All right, so let me take a moment and talk about a few of the popular binding expressions that you'll probably see in Zaml. We've looked at quite a few, but I want to clarify this just to make sure that you understand how this works. There's so many permutations that I couldn't possibly talk about them all. You need to be able to read and interpret this and understand how data context flows down into the controls. So first of all, you might see just a binding expression with open and closing curly braces with just the word binding. And so it's basically saying bind to the current data context. So whatever my parent bound to, I want to bind to that as well. And we already saw that just a moment ago when we were looking at, I think, yeah, that was on the hubpage.zaml hub section 1. And since my parent binds to groups and I want to display group titles, I'm going to bind to groups as well. So I'm just going to use the binding word by itself. It says bind to whatever my parent bound to, in this case, groups. Okay? The next binding syntax you might see is something like binding my property. And we can see that here in any of these item templates that are defined up here in the page.resources. So for example, this text block is binding to the title property. Well, we would assume that its parent is a sample data item, right? So we're binding to, you know, as the data context flows down from the grid view, it's set to items, and it flows down to the item template, the standard 200 by 180 tile item template. Then we would expect each individual item in the items collection to have a title property in an image path. So that is basically we're saying bind to the my property of the current data context. All right. We might see binding my object dot my property, and we saw that here in the item page.zaml when we were defining the data context for the entire page. Give me the default view model, but specifically give me one property, or in this case, one key called item. Okay, so bind to the my property or key property of my object. My object should be a property of the current data context, which it is. Okay, and then binding, and then element name equals my text box, path equals text. So if you see this, it basically is saying bind the data context is another control with the ID or the name my text box, and I want you to bind to the text property of my text box. All right. And then finally, the last one we'll look at, although there are plenty more, is binding my object relative source equals relative source self. So bind to, and we've seen this, you know, anytime we've defined a data context here or here for the page, right? Basically this. So we're going to bind to my object, which should be a member of the current class. So I would expect in this particular example on screen that my object would be an object or an object graph defined as a partial class for this page, which, as we know, is indeed the case. Okay. All right. So in addition to these, there are many more advanced scenarios, many more. If you want to see some more examples and you want to see them in context, then check out this example, the Zaml data binding sample. Now, admittedly, this is a Windows Store app project. However, most of the ideas will transfer over to binding with the phone's API as well. I'd also recommend that you take a look at this data binding article. Admittedly, this one was for Windows Presentation Foundation. However, many of the ideas in this article, as you read through the various sections here, transfer over to binding with the phone as well, because they're all based on Zaml, the same core fundamental technology that's allowing you to do the binding. All right, so my final word on binding is this. In our example so far, we've only seen one side of data binding from a data source to the Zaml. However, you can also bind in a two-way fashion, allowing changes via changes to the data via the input controls like a text box, a combo box, checkbox, a radio button, and so on. So any changes made to those controls will affect the underlying data source, and any changes to the data source will affect the control. So there's that two-way relationship. In fact, this two-way binding is a basic tenet of a pattern that's known as MVVM, or rather model, view, view model, which we'll examine in the next lesson. So just to recap before we conclude, we've covered a lot of ground in this lesson, admittedly. Binding, and specifically data binding, is a key concept in building data-driven applications based on a data model. It's how you marry the data that's stored in a data file, like our sample data.json file, to the user interface, and so that they can be displayed, that data can be displayed on screen in a declarative fashion using Zaml. So my recommendation is that you keep your structure as flat as possible as you're getting started to ensure that you don't confuse yourself as you set the data context for your app's object graph. So again, the more layers you have and the more the data flows from the page level all the way down to the control, the item template, and so on, the more room there is for mistakes and confusion. I'll have to admit, when I was getting started, was confused a lot. So, it can happen to any of us, right? All right, so we're going to pick this back up and talk more about the philosophy behind all this binding stuff, which is MVVM. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in the previous lessons, as we've been working our way up to this point, we learned about the data model and how it's used as the data context for pages, and then how that data context flows from the page down to various controls as they're embedded within other child controls inside of other child controls and so on. And when we talk about the data model, we're talking specifically about the sample data source like you see on screen right now. We learned about the binding syntax that's used by Zaml to bind the data model that was exposed by the code behind to the declarative controls in our Zaml. The Hub App template employs a design pattern in software called MVVM, or rather Model, View, View Model. At a high level, MVVM seeks to separate concerns, extracting code that's specific to presentation, or rather the view, the XAML that defines the user interface, and extract that from the code that's specific to the domain, or rather the model, or rather the sample data group and the sample data item classes and their relationships. And separate that from the code that coordinates the activities of the model and provides the view with access to the model, which we call the view model, or rather, in this case, the sample data source. So MVVM is a slightly advanced topic, and frankly, I'm not sure that I'm qualified to provide an exhaustive explanation of it. Unfortunately, even some authors and books that have attempted to clarify this topic have not always done a good job of doing it either. But what I can do is I can show you the basics of how and why MVVM is employed in the Hub App template so that you can begin to understand the thought process that influenced the organization and the design of the code inside of the template. Now, obviously, my goal is to help you better make changes to this template, and a fundamental understanding of MVVM should help you to build a mental model of the responsibilities that each class has, each as it is basically a piece of a larger puzzle. All right. So let's start with the notion of a model. In software architecture, a model is a representation of a given business or domain problem. If you were building an accounting system, your model might have classes for things like an account, a customer, credit, debit, and so on. If you're building a game, your model might have classes for things like planet, spaceship, soldier, weapon, and so on. If you're building a media app, your model might have classes for sound or video or categories of sounds and videos and so on. So in most MVVM implementations that I've seen, the model is little more than just a data structure, a class that defines properties and basically contains the state of a given object, but almost no methods to implement business logic. So just to provide a little guidance here, many believe that this is actually an anti-pattern, or rather a bad idea. It's often referred to as anemic domain model, in which business logic is typically implemented in separate classes which transform the state of domain objects. But we're going to ignore that for now. I just wanted to throw that in for what it's worth. So you can see examples of a typical model that utilizes MVVM in our Hub app template. The sample data item and the sample data group classes, they have lots of properties, but they have no methods that actually operate on those properties outside of the constructor, which initializes the state of a given instance of each of these classes. All right. So good examples of the notion of a model. Let's roll all that back up. Okay. The next is the view, and the view has the responsibility of the presentation of the model. It does this through binding a core component of Zaml through the binding syntax that we've already seen. So what does the view bind to exactly? Well, we've seen examples of it binding to data via a view model, which it would call the default view model in the code behind. But later in the series, we're going to see how the view binds to commands that are implemented in the view model as well. Commands are essentially methods that perform logic and respond to the user's interaction with the view. More on that later. So then finally, the view model, the last part of model view model, is the key to making MVVM work. The view model provides a layer of abstraction between the view and the model. We can see this implemented in our sample data source right here. That's the purpose of that class. It has to load data into instances and collections of the model classes to create an object graph. When I use the term object graph, I'm referring to instances of classes that are somehow related. We see this at work with the get sample data async method, and we've already talked through kind of the pseudocode for what this method does. But once it has sufficiently created that object graph from data in a file and created instances in memory of our sample data group and sample data item objects, then there are various ways of returning parts of it based on the needs of a given view. So it's these three methods here, or this public getter for the group's public property. All right. So you might wonder whether the code behind, for example, the hub page.zaml.cs file for the Zaml is part of the view or part of the view model. After all, first it retrieves the appropriate data for the given view in the navigation helper load state method like we've seen here. And then secondly, exposes the data that's retrieved from the view model as a property to the Zaml here in our, I guess the public side of this, the default view model here. All right. So I think of these as merely helpers to the main job of the view, and therefore I would classify everything here in the hubpage.zaml.cs as part of the view itself, not as part of the view model. All right. So when I say all that to say this, the view should merely observe the data that's exposed by the view model. In other words, it should watch the collections or the instances of objects that were delivered by the view model for any changes and then react to those changes by changing what's displayed in the view. And this is called observability. Now we're getting to that observe keyword that I wanted to ignore when we were looking at observable dictionary and observable collection and things of that nature. So if an instance of an object that's part of the collection that's managed by the view model is added or removed or updated, then the view should be notified of that change. Now, fortunately, all this plumbing that's required to make this work is baked right into Zaml. But from your perspective as the developer, how do you notify the view that something is changed? Well, in order to make that work, your classes have to implement the INotifyPropertyChanged interface. So by implementing the INotifyPropertyChanged interface, your class basically will say, you can observe me, you can watch me, and I'll let you know whenever something inside of me changes. So I don't really have a complete example to show you, but I figure I'd throw something together really quick just to show you how you would go about implementing INotifyChanged for a given class so that it can be at that point observable, and any changes to that class would then bubble up to any view that was observing that particular object, so that if the object changes and if its properties change, then the view will update itself to reflect that change. All right, so what I'll do here in the common folder, and I'll delete this, but if you want to follow along, we can do this. So I'm going to add a new class, and we'll just call this class sample. All right, and we're going to throw this away. This doesn't mean anything, but I'm just going to start typing away here. So I'm going to go class sample, and I will INotify property changed, and I'm going to hit control period on my keyboard, add the using statement. So add using system.component model. All right, and then I'm going to hit control period one more time on my keyboard. I'm going to say implement interface INotifyPropertyChanged. So that control period technique, we learned about that in the C# Fundamentals series. If you're not familiar with that, please go back and watch that series, okay? So I'm going to go ahead and implement the interface. And now notice what it does. At this point, it merely is implementing an event called property changed event handler called property changed. All right, and so the intent here is that we will fire off an event, and anything that watches that event will be notified whenever a change happens. Okay, now there's one more thing that we're going to need here, and that is a helper method that will essentially fire off this event, and it's the same in every class that you'll create, or basically the same. So I'm just going to paste it in, and we're going to need to add the namespace system.runtime.compiler services for this caller member name. So as you can see, really the purpose of this is that it's going to throw or fire or trigger off this event called property changed that we've defined here, and anything that's watching the instance of this class is going to be notified of a change. So now all we need to do is implement some properties. Now we can do something the old-fashioned way, or the newfangled way, I guess you could say, of just doing prop tab, and that will allow us to create auto-implemented properties. But in this case, we're going to need to do prop full tab, because what I want to do is create a string called name, and then whenever anybody, any of our code changes the name property, we want to say and fire off this property change notification and say, hey, name property just changed. It was Bob and now it's Robert. All right. So in order to do this, we're going to add some code here in the setter. And so we'll do something like this. If value has indeed changed, so if the value is not the same as the current name, then what we want to do is set it like so. And then most importantly for our purpose here is to go notify property change, and we'll pass in the name of the property. In this case, the name of the property is name. All right, great. All right, so by implementing this iProperty changed interface on our class, we must agree to raise an event called property change. This is the fundamental wiring that allows other classes, like the user interface classes in our Zaml, to be notified whenever changes to an instance of this class has occurred. So it'll say, hey, now go update yourself to reflect this change that just happened. So this event then is then triggered in the notify property changed method, like we saw here just a moment ago, right here. And whenever the set operation is performed, calls that property, triggers that event, and now the event is fired, and any class that's listening to for that event, like certain user interface classes in the phone API, they're going to have an opportunity to refresh the data that they display. All right, so having said all of that, the Hub app template doesn't have any classes that directly implement INotifyPropertyChanged. Like if you were to go and just do a search for this throughout the project, find and say, I want to look throughout the entire solution, with the exception of this particular file, you're not going to find anything that implements it. So how in the world do we have observability when nothing implements INotifyPropertyChanged? And the truth of the matter is that whenever we use any of the observable collections, whether it is the built-in observable collection of T, as well as that custom class that we saw, that observable dictionary, it's based on classes that ultimately implement INotifyPropertyChanged. So the moral of the story is that as long as we're using some observable collection, whether it be this custom observable dictionary or observable collection or something else, to expose collections of objects from the view model up all the way to the view, then we'll get observability at the collection level. So observable collection of T is essentially a list of T with the added superpower of observability. All right. So there are a couple of important aspects about this. First of all, the sample, let's get back here. Sample data group. There we go. Sample data group has an items property, which is an observable collection of type sample data item. Therefore, whenever new sample data items are added or removed from the items property, the property changed event will be fired by the collection, and any user interface elements that bind to that items collection will be notified that, hey, you've got a new item that you need to render in your view. Now, unfortunately, this is a bit anticlimactic because we don't see this happen in the template as it stands right now. In other words, there's no functionality that requires us to remove items or add items to the collection throughout the course of use. I mean, that's just not what was built into the template, but we'll see this in use later on as we build another example based on the Hub app template. All right. The second important aspect that I want to point out is that if we want observability at the sample data item level, so let's drill into sample data item. As you can see, as it stands right now, it does not implement INotifyPropertyChanged. And so if we had functionality in the app as it stands to edit details about a single sample data item, those details would not be reflected in any user interface elements that bind to our collection of sample data items or individual sample data items, because we don't implement it at the property level like I did here in this sample.cs, where I implemented it at the property level. It's implemented at the collection level. Therefore, whenever we make a change or we set or edit a given instance of sample data item and change its title or its subtitle or its description, that notification obviously won't be fired off because we haven't implemented it. So as we move forward and build real applications based on the Hub app template, we'll have to utilize this technique of implementing INotifyPropertyChanged on our model classes in order to make observability happen at the property level, at that most minute level. Okay? So that's really all I wanted to say. In this lesson, we talked about two very important ideas. Hopefully you can see the larger role of MVVM and its influence on the Hub app template. I mean, it's what defined how the Hub app template works and how it binds to data, how the code is laid out, and what the responsibilities of each class really are in the larger scheme of things. The design pattern shaped and guided the developers of the template to provide an implementation that separated the concerns of the app and delegate responsibilities to certain classes. So furthermore, hopefully now you understand, at least at a high level, why the Hub app template was using observable collection of T and that custom observable dictionary. It provides a convenient means of updating the user interface controls, giving them the notification to update yourself because something changed fundamentally with this collection of objects that I have. So there are more aspects to MVVM that we're going to cover in this series. I'm going to talk about commands a little bit later on, which allows the user interface to bind to events like a button click to a method in the view model. And it allows us to wire things up without having to get down deep into the details. You can have somebody working only on the user interface and another developer working only on the view model, and they can work on the same project at the same time, because all the user interface developer needs to know is that he needs to bind that button to that command. Okay, so that's one of the tangential benefits of using MVVM, especially for commands. We'll talk about that later. All right, that's all I have to say for now. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So we've spent a lot of time examining the Hub App project template, and for good reason. We can learn a lot of good lessons from it. It illustrates many important concepts that we need to know in order to move forward and build more complex phone apps. So we're going to turn our focus back to the sample data source, which I have loaded up right now, and I want to talk about some keywords that I have completely ignored up until this moment. Specifically, if you take a look at any of the methods, let's just pick get groups async, for example. You can see that there's this keyword async, this type task, and it's formally known as task of T result. All right, in this case, it happens to be an IEnumerable of sample data group, but it can be any data type. So task of T result, and then finally this await keyword. Well, these keywords or types are newly added to C# 5.0 and are generally referred to as the new async features, which is short for asynchronous or asynchrony. In a nutshell, this new feature of the app, this new feature is a simplified way of improving the performance of the app, making it more responsive to the end user without adding the complexity of writing multiple threads for the software developer, which is known to be a very complex process, especially for new developers. So if you call a method on the Windows Phone API or some other library that supports the async features, and that particular method could potentially take a long time, then the method will say, tell you what, I promise to get the results back to you as soon as possible, so go on about your business now, continue executing, and I'll let you know when I'm done. And so then your app can continue executing and can even exit out of method contexts. And at some future point in time, when the method you called finishes executing, it completes its promise, returns the results back to you, then everything that was depending on those results can then execute. All right, so another word for this in computer programming terminology is a promise, and you'll see that implemented in other programming languages like JavaScript, for example. They have promises. So under the hood, whenever you compile the source code, the sample data source class, for example, the compiler will pick apart the source code and will implement it as a series of complex statements in the intermediate language in order to allow this all to happen flawlessly. And typically it'll do it without the use of multiple threads in most cases due to the nature of how this really works. And we'll talk about that in just a moment. But simply by using these keywords in the right spots, you get all the benefit of asynchrony without having to understand the complexity that goes on to make it work. So that's very cool. So async is best used for operations that have a high degree of latency, but are not compute intensive. So latency versus compute intensive. What's the difference? For example, the getSampleDataAsync method retrieves data from the sampledata.json file, like right in these lines of code, right? And so then it loads all of that data into an object graph of the sample data group and sample data item instances below it. That could potentially take a second or two, which is really an eternity in computer programming. Another example might be calling a web API to get some data from an online service. So relying on communications over the internet could potentially take a long time. It could take a half a second, maybe 2 seconds in order to complete. But the phone's processor is not busy during this time. It's just sitting there waiting for a reply back from the online web service, or waiting for the file to be loaded off of the phone's memory storage device, flash memory or whatever the case might be, into memory. And so this is known as I/O bound operations, or in-out. Anything that works with the file system or the network or the camera and so on involve I/O bound operations and are good candidates for async. In fact, the Windows Phone API designers decided to bake async into all I/O bound operations, forcing you to use this to keep the phone responsive to the end user. So contrast that to compute-intensive operations such as a photo filter app. It has to take a large image from the camera and then run complex mathematical algorithms to change the colors or the position of each pixel in the image. That could take a potentially long amount of time as well, but in that case, the phone's processor is hard at work. So this type of operation is known as a CPU-bound operation. This is not a good use of async. In this case, you'd want to consider a background worker which helps to manage the threads on the Windows Phone platform. If you're developing in .NET, you might prefer to work with threading via the task parallel library instead, or revert back to managing threads manually, which has been an option since the very earliest versions of .NET. So understanding multi-threading, the parallel programming, and the task parallel library, and even background workers on the Windows Phone API are way beyond the scope of this series and specifically this lesson. It's a large topic, and I'm not going to lie to you, it often makes my head spin when I sit down to learn more about it. So if you want to learn more about async and how it applies to the phone and the Windows runtime and things of that nature, then check out this video that I created a year or two ago, working with async methods in the Windows runtime on Channel 9. And be sure to read the comments below it where I further explain this idea as people ask questions. So back to the topic at hand. Async is for those common occasions when you have a blocking operation that is not compute intensive, such as our case here, where we're just waiting for these lines of code to complete, specifically where we're waiting to get the file from the storage device and then waiting for that string to be converted into JSON objects. So in this case, we use the await keyword, mostly because the Phone API forces us to, by virtue of the fact that both of these methods return an type async operation of tResult, as you can see here and as you can see here, and I'll talk more about that in just a moment. Actually, the async operation of tResult is just a specialized version of tResult that's used by Windows and the Phone API. All right, so that's all there is to it. So by virtue of the fact that each of these return essentially a task, we have to await the results. And you'll see awaitable methods with a common convention. They all end in the word async. And so when the developers of this template created these methods, which rely on async methods, they too share that same convention of being named with the word async at the very end, indicating that they will return a task and are to be awaited. Okay? So furthermore, any method that uses, like I just said, an awaitable method must be marked with async in their method signature, and if it's supposed to return a value, it must be wrapped in a task of tResult like we've done here. All right. So in this case, notice that we're just returning the keyword task. Task is the return value. What's returned exactly? I mean, what is this really doing? Well, it's really just returning a promise. So this is just a promise that, in this case, get sample data async will finish running, and when it does, any code that calls this method, getSampleDataAsync, will be notified. So here again, a lot of compilation magic happens at this point, the likes of which I don't pretend to fully understand. So in the case of getItemAsync, notice that its return value is a task of tResult. So a task of, in this case, sample data item. But what is really being returned here? What really is the value that's being returned to whatever calls this? Well, here again, it's just a promise that getItemAsync will finish running, and when it does, any code that's calling getItemAsync will be notified and rewarded with an instance of, in this case, a sample data item that it can then use for its data to bind to, or whatever the case might be. Again, at this point, a lot of compilation magic happens. So in both of these cases, the presence of an awaitable task essentially means that any code that calls our methods can continue executing until it absolutely positively needs the result of those methods in order to proceed any further. So let's back up for a moment here. Again, remind me, why are we doing all this? It's in hopes of making our app more responsive. This operation should not be blocking the phone's processor from taking on other tasks like answering a phone call or running background tasks on behalf of other apps. It won't prevent the user from selecting any of the hardware buttons on the phone and getting instant results, an instant response. So that's really the value of using these async methods, to make the phone extremely responsible even when it's tied up and waiting for results to finish before it can complete. Okay? Finally, if you didn't understand much of what I just said, let me make this really simple and very practical. Certain methods in the phone API use awaitable tasks to make sure that they return control back to your code, thus making your app hopefully as responsive as possible. Those are usually marked with the term async at the very end. And if you look at what they return, they will typically return an iAsync operation of tResult. That means that it's using this asynchrony inside of its API. Therefore, whenever you need to use one of these methods, and let's just go down here below this one here, and let's create a fake method like so. So here's just a fake helper method. And now I'm going to actually paste in some code, and I just grabbed this from the method that we'd already created. Notice that we're going to get a red squiggly line under get file from application URI async. And it shows us the proper usage in the second line of IntelliSense. Usage storage file x equals await get file from application URI async. So the first thing we need to do to resolve this is type in the word await. However, we still get a red squiggly line, and we can see that the error is that the await operator can only be used, we're looking at the very bottom here, can only be used within an async method. Consider making this method async. All right, so we're going to get rid of the word void, and we're going to call this async, and then we're going to return a task, like so. And that should make your method now awaitable, and it's able to utilize any APIs within the phone's API that uses this async method. Finally, you should probably rename this to async as well, just to give any consumers of that method the heads up that they're going to need to call your method using the await keyword. All right, so let's do this over again, but this time I want to return a value. So let's, instead of using void, let's actually return storage file, like so. And we might even just add return file, like so, okay? And we'll get rid of await. So we've reset this example. Here again, if we hover over, the first thing we're going to need to do is add await. We'll need to add async, and then we're going to promise to return an instance of type storage file, okay? And at that point, everything gets resolved. Great. You might see a different error pop up. It's just IntelliSense was momentarily confused. Don't worry about that. All right. So hopefully that makes it very practical for you as you go about using awaitable tasks and awaitable methods inside of your app. All right. So to recap, the big takeaway in this lesson is what async is, how it works, what scenarios it was designed to address, and its overall purpose: to keep the phone and your apps as responsive during long-running I/O-bound operations so that the user can answer a phone call, click the buttons on the face of the phone, and so on. All right? So hopefully that clears up at least its purpose. You don't have to understand everything about it in order to utilize it inside your apps, because you will absolutely have to. Great. All right, so we'll pick up in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So you might think it's an odd transition from talking about MVVM and awaitable tasks and to something rather fun and mundane like playing video and audio. However, this is the last lesson before we go off and we build an entire application based on the Hub app template. And I'm not going to spoil the surprise, but it will involve playing audio and video. So I want to show how to work with audio and video before we jump into that part of building our app. So to isolate that, I'm going to build a new project. We'll select just a Hub app template and call this sound and video, and this will allow us to discuss the MediaElement by itself. And so what I'm going to do is just illustrate some very simple scenarios in this lesson, just a bit more than we're actually going to need for our full featured app in the next lesson, but not enough to go off and create some great audio player app that you could sell on the store. You're going to want to consult the documentation if you have a more advanced scenario that you want to enable. So what I want to do is open up the mainpage.zaml, and I'm going to go and paste in some Zaml. Let me move this down, make this smaller, make it like 36. There we go. And I'm just going to select and remove the grid and just paste in the stack panel layout instead. And you can see that I pasted in a MediaElement control. I just set its height and width to 10. It doesn't really have any visual player, or at least it won't for just playing audio at this point. And you can see that I set the source property for the MediaElement to a WAV file in my assets folder. Now, I don't have that currently in my assets folder. There should be some assets that are available whenever you download this video. There should be a zip file that has some additional files in it, and so make sure you open up lesson number 21 assets folder, and I've just taken that and dragged it to my desktop here. So I'm going to choose coffee and duck.wave. Both are files from that assets folder. I'm going to drag and drop them into the assets folder in my Solution Explorer, and then I'll move my Visual Studio back into my recording area like so. Great. And so now what I want to do is run the app. Okay, and hopefully, I'm not sure if it recorded it in the video or not. However, I have a set of headphones, and I could hear it, the quack, come out of the headphones. So I know that it actually did play. In fact, let me put my headphones around my neck so I can listen to it and monitor it in the future. So it might be a little anticlimactic from where you're sitting and watching this video, but if you're following along, you should hear a quack come through your speakers as the program executes. Now, say for example, I don't want the sound to play immediately. I only want it to be triggered whenever I click a button. So let's make some changes to our app. What I'll do, first of all, is I'm going to set autoplay attribute equal to false. So that will stop it from playing right away. And then I'm going to paste in the code for a button that I've got here on my clipboard. And what I want to do is, you can see I have a new button here in the upper left-hand corner. And I'm going to now, whenever somebody clicks that button, the click event will fire, and we'll handle it with a play sound button underscore click event. So I'll right click and select go to definition. And here what I want to do is something simple like myMediaElement.play. All right. And we're going to run the application again. And I'm going to hold this up so I can hear it if it does quack this time. Yep, I can hear it. So very good. That works. I encourage you to follow along and make sure that this works on your end as well. All right, so what if I want to use this same media element for multiple sounds or videos? Well, first what I would do is I would remove the source and autoplay attributes like so. And then what I want to do is go back to the main page.zaml.cs for the click event handler. And I'm going to set my media element source property equal to, and if I hover my mouse cursor over the source property, it takes a URI object, and a URI just represents a location. It's kind of like a URL, but it can include local networks and file systems. So we're going to do a new URI, and then we're going to give it a location as a string. So there's this special like syntax. So ms-appx:/// kind of resembles http://, right? But we're basically saying look inside of the current package for this asset. So we're going to look in the assets folder /duck.wave, all right? And then we're also going to give it an optional URI kind. And this just says where should it look for this? Should it be relative to the current folder, or should it be an absolute path? And what we're going to choose is we're just going to say URI kind dot relative or absolute, and that basically says let the runtime figure out whether it's absolute or whether it is or relative. All right, so we're not going to declare that. This should be sufficient for it to find the asset that we're looking for. All right, so let's run the app again. And I'm going to click, and I can indeed hear the duck quack. Awesome. All right, so that helps us utilize one media element that we've defined to play potentially multiple sounds. What if we wanted to display video? Well, in that case, what we'll want to do is make our media element larger, because it's actually going to display inside of this, and so we're going to need to give it some room here. So 400 by 240, and then we'll set some margins just to make things look pretty, like so. You can see when I put my mouse cursor in it, we get this outline of it and where it'll be displayed. Great. And this time what we're going to want to do is in the we're going to add another button. So beneath our current button, we'll add another button that's play video instead of playing the sound. And here I'll right click so that we can go in and define the play video button underscore click event handler. And here what I want to do is, and I'll just paste in this code, instead of playing the duck.wave, we want to play the coffee.mp4 file, which we dragged into our assets folder earlier. All right, so let's go ahead and run this app and see it at work. So the first thing I'll do, just to make sure that the sound still works, and it does, is I click the play sound button, and now I'm going to play the video, and you can see it's playing the MP4 file. It's me just making a cup of coffee, nothing all that interesting. But what if we wanted to pause the video during playback? Well, I would need to keep track of the current state of the media element. And I suppose there are many different ways to do this. I'm just going to show you one way. First of all, I'm going to imagine the various states that the video could be in. It could be playing currently, it could be paused currently, or it could be stopped. And so what I'm going to do is actually stop running this app. And I'm going to begin by creating a new enum. So public enum media state. This is something I'm just cooking up here off the top of my head. Stopped playing and then paused are the various states that we could use. And so then I'm going to use that enum to perform the following logic. So first thing I'll do here is I'm going to add a private property called state, or a private field called state, that will be of type media state and initialize it to the fact that the video is currently stopped. And then inside of the play video button underscore click event, I'll just paste in some code here. Let's comment this out. And I'll paste in this code. All right. And so what we'll do is we'll check the current state. If the state is currently stopped, then we'll play the video. However, if the video is currently playing whenever the user clicks the video button, then we'll pause the video. If the state of the video is currently paused and they click the play button, then we will continue playing from that point on. So let's run the app now. And we're going to click play video. And now the scenario is this. I'm going to click play video again, and it pauses the video. And I'm going to click it again, and it continues playing the video, and I can continue doing that. All right. There's actually one little bug in this app as it stands right now. Well, first of all, before I talk about that, notice that we're just calling the play method and the pause method depending on the current state of the media element. There isn't one bug, though. If the media element does get to the end of the video, we want it to set the state of the video back to what it was originally, which was stopped. So to do that, what we're going to do is go back to our media element, and here we're going to add the media ended event handler, and we'll create a new event handler for that. I'll right-click, select, go to definition, and then inside of here, we'll just say state field equals media state dot stopped, and that should take care of that situation. All right, and I'll leave you to test that on your own. But that's essentially how I would implement that playing and pausing scenario. I could even change out what the button looks like based on the current state. Didn't choose to do that here. All right, but hopefully that gives you some idea of how to reference assets, video and audio assets in your app, how to play them, and then how to pause them, and then based on their state, continue playing or stop them, or whatever the case might be. All right? So as I said at the outset, there are more features of the media element that than what we would discuss in this lesson. However, this will at least get you started thinking about what's possible, and then in the next lesson we're going to put many of these ideas together into a single app, and that's going to be exciting. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this exercise, what I want to do is build an entire app based on all the lessons we've learned about the Hub app template. I want to show you how easy it is to transform that Hub app template into something completely different. In this case, we'll create a media application that will display images and recipes of cupcakes, as well as videos, instructional videos of how to make cupcakes. So without further ado, let's get started because we've got a lot of work to do and it's going to take us a while to work through it all. So I'm going to create a new Hub app template called I Love Cupcakes. And I want to emphasize here that I'm going to be going pretty quickly, and please pause the video and follow the steps that I'm taking here. Even if it takes you a few moments to catch up with me, that's fine. Just pause the video and make sure you follow along. The first thing I want to do is to kind of set up the example. I'm going to remove all the assets. We have new assets that we're going to use, so we're going to delete all the items in that folder. And you should be able to download the the code and the assets for lesson number 21 for this lesson. It is available from wherever you're currently watching the video or wherever you originally downloaded the video from, like on channel 9. Inside of the zip file for lesson 21, there should be an assets folder. And inside the assets folder, you can see that there's a number of JPEGs and PNGs and MP4s, videos. And what I want to do is just select everything except this last file. We'll come back and get the sample data.json file in just a minute. I'm going to right click, select copy, and then go back to Visual Studio. And I'm going to paste in all of those assets like so. And since we're working with the assets right now, I'm going to go to the package appx manifest, and I'm going to change the display name to I-love or space cupcake. So I space love space cupcakes. And then under virtual assets, we'll go ahead and use the scaled assets. I'll use the 240 scale for each of the logos. Let's go ahead and select the assets folder to start off with the I love cupcakes -170 PNG. I'll select the I love cupcakes -360 PNG. And the next one, I'm going to select the I love cupcakes. I think I call it the 744 PNG. It's this pink one. And then the 44x44 logo, I'll use the scale 240 and use the 106. So I love cupcakes -106.png. And the store logo, I'll use the scale 240 for the 120 by 120 pixel version of I love cupcakes -120 PNG. I'll skip the badge logo and go to the splash screen, and we'll select the I love cupcakes -splash.png. And just pick one of these of the logos, and we're going to want to show the name whenever it is pinned to the start menu for the medium size and the large version of our logo. Okay, so I think that's all I need to do there. I'm going to close this, and I don't think I need to make any changes to the app Zaml.cs. What I want to do is start with what I perceive to be the most challenging aspect of this, and that's going to be to remove all the stuff we don't need. So in my mind, that's two things. It's going to be all of the hub sections we don't need. And in my mind, there's going to be only two hub sections needed. A hub section that will contain images of cupcakes. Then you click on one, and it'll go to the recipe for that cupcake. And then a second section, hub section called videos, that will just contain thumbnails of a given video. You click on that, it opens up and displays and plays the video. All right. So as you can see here in the hub page, we got rid of our assets, so we lost the background that we were using. I'll fix that here in just a few moments. My first order of business, however, is to get rid of the hub sections I don't need. I know I don't need hub section 1 because that was just a listing of groups, and we're not going to have that anymore. Don't really need that. I do want to keep hub section 2 and hub section 3. I think they'll be just fine the way they are, but I'm going to get rid of hub section 4 and hub section 5, so I'll comment those out. Great. I'm going to go back up here to the hub itself, and I'll change the application name here to I love cupcakes. And I'm not sure that it's going to pull from this header when we go and run this, but for the purpose of the designer, it changes it for the moment. The background is using a theme resource called Hub Background Image Brush. I'm going to go to its definition, which happens to be in our app.zaml, and I'm going to change where it's pointing to. Currently it's pointing to Hub Background, and what I want is for it to point to I love cupcakes background. So I love cupcakes background. I think that'll work. So now when we go back to the hub page, it does refresh. Awesome. All right. So also I'm going to change the hub sections currently it just says section 2 and section 3. I can do better than that. I'm going to change this to recipes, and the header for hub section 3 to videos, like so. Now we're still working with dummy data. This will work for now. Let's run it and see what we get so far, just to make sure we haven't broken anything right off the bat here. Splash screen works. Background works. All right, our data is not good, and our application name reverted back to something else. We'll have to find wherever that's saved, but I am able to go between the recipes section and the video section, so that's good. Now, I guess the next order of business, as far as I'm concerned, well, hold on a second. Before we do that, let's go to the start page, and then let's see if we can find the I Love Cupcakes logo for our app, and it does exist. I'm going to just hold down on it and select Pin to Start, and so now we can see the larger version. We can see the text on it. Great. Let's go and make the smaller version and then the very large version. Okay, so those all seem to work just fine. A little more creative there, and we can launch it again. Awesome. All right, so all is well so far. The next step that we're going to need to take is to make some modifications to our data model. And this is where things can get a little bit tricky if you don't pay attention to exactly what you're doing. The big modification that we're going to make is to work with the sample data item. We're going to add an additional property. So prop tab, and it's the type property is either going to be set to video, because a given item will be a video, or it'll be a recipe. Okay, and that'll help us in a little bit decide what to display on the item page .zaml. But at any rate, now that we've created that new property in the constructor, after string title and before string subtitle, I'm going to add type here. So string type, and then I'm going to set it here like so. This dot type equals lowercase type, like so. Great. And you'll notice that I leave the names of the classes, and I leave a lot of the properties for both the sample data item and the sample data group alone. Now, if this was a real app, I'd take the time to change the names of these sorts of things, but I'm trying to go quickly here, so just keep that in mind. The last change I'm going to have to make is actually in this the get sample data async method. And currently right now we are creating a new instance of the sample data item using the constructor. However, the constructor's signature has changed, and we need to accommodate that by passing in type. So item object type get string, get string, like so, and that should satisfy it, hopefully. Save everything. Now the next part is tricky as well. There's a lot of data here, and we don't need most of it. And we want to replace most of this data with our application-specific data. Now I could go in here and spend a half hour and edit all of these entries. However, I have a better idea for you. What I'm going to do is just delete this sample.json file. First of all, notice that the sample.json file, its build action is set to content. We're going to need to remember that in just a second. So let's go ahead and delete sample.json, and I've given you a sample.json with all of the data that I want you to use for this project. So I'm using a shortcut here, admittedly. It would take a little bit longer to recreate this with the data that you want, but really all I did was just edit that existing sample.json, and I changed the various properties to the things that I wanted. So references to the images that I wanted to use, and the names of the cupcakes and things of that nature. And we'll take a quick peek at it in a minute here. But I'm just going to drag and drop it into the data model folder like so. And then I want to select it and make sure that the build action is set to content. Otherwise, this will not work. Okay. So as you can see, inside of my sample.data.json file, I have, for example, like title, recipes, subtitle for awesome cupcakes, image path, cupcake01.jpg, and so forth. And hopefully all of these are correct. I haven't taken the time to really look through them. But at any rate, you can see also that each of the items for the groups either have a type of recipe or a type of video here in this group 3. All right. So now I'm going to cross my fingers and I'm going to try to run the application and see if we get my data into the app. And it looks good. We have our images coming up here for our recipe pages. And then if we go to the next page, we see the thumbnails for each of the videos. I'm very happy about this. All right, so we're making great progress. The next step is whenever somebody selects one of the items on the hub page, that it will go to the item page. And what we'll do is, since both of these hub sections have their item click set to the same item view underscore item click, so let me select it and hit F12 here. What I want to do is build some intelligence into this process. So if the type is a recipe, then I'm going to send them to the item page.zaml. But if the item type is a video, then I'm going to send them to a new video page. So let me add a new item. I'm going to add a basic page. I'm going to call this video.zaml. And here on this page, I am going to add here a media element, all right, named my media element. So that's the first thing that I need to do. The second thing that I want to do is then here in my navigation helper load state, I'm going to paste in the following code. And the first thing that I think I need to do here is to add the async keyword, right? To make that error go away. We need the notion of a sample data source. So since sample data source is in the data model folder, we need to add that namespace. So I'm just going to hit Control period on my keyboard to add the using statement for I love cupcakes.data. All right, so that should fix that problem. And then let's see, the page title. I think I may have to go back here. And what I'll do is give this a name of page title. So name equals page title, like so. Then I can set that programmatically from the code behind, like so. That should work. Great. And what I'm essentially doing here is grabbing the navigation parameter, which should be the item name, and then I'm going to look up that particular item. So I'm going to pass in the unique ID, and I will send that unique ID to the get item async, which should return back one item from my sample data source. And I'll set that as the default view model for this page. Now I'm using the unique ID, which if you look at the sample data, each of the videos have this unique ID that matches the MP4 file name. So frosting mix MP4, cupcake mix MP4, cupcake pour MP4. Those are the names of the unique IDs, so that I can just concatenate them together and set them as the URI to create a URI to set as the source for the media element. All right, and then the media element will just automatically play whenever it's loaded. Okay, so that should take care of that. We're going to do something similar then on our item page.zaml. So let's load that up. and see that it's already, the binding is already working to some extent. But what I want to do in the content root grid here is paste in a stack panel. So we're going to bind an image to the item's image path and then the content from our sample JSON, from our sample data item. And so we're going to do something similar to like we did in the video.zaml, in the item page.zaml, inside of the load state. We're going to, I think we can just keep that the way it is. Let me think about this for a moment. Yeah, no change will be necessary here. So this will work as is. And we'll be able to just bind to the various the path, the image path, and the content from the sample data item that we're currently binding to. Great. Now we need to change, you know, like the my application to I love cupcakes. We'll probably need to make lots of those little changes all over this app. However, the last thing we're going to need to do is go back to the hub page.zaml, and inside of the item click, we're going to need to make this. This is going to be the biggest change that we're going to need to make. And so we need to decide, we'll get rid of all of this. We need to decide what's been clicked on. So what is the type of the item that's been selected? So we're going to get the clicked item, we're going to cast it to a sample data item, and then grab off its type property. And so if that type is a recipe, then we're going to navigate to the item page. But if that type is not recipe, if it's video instead, we'll navigate to the video page. In each case, we'll pass in the item ID, that unique ID that we're gathering off, again, from the clicked item, casting it to sample data item, then grabbing the unique ID. So that's pretty easy, actually. All right, let's try and see what happens. So let's click on Cinnamon Swirl. All right, and we're not getting the image, nor are we getting the text here. So we'll have to look into why that's not working. Let's see the video. Let's click Pour Batter. Oh, but we did get this to work, where we're pouring the batter. Very cool. Let's go back. Let's click Prepare Frosting. Very nice. Mix ingredients, another video. Awesome. So we just got to figure out why when we click on one of these that we're not getting all the information. The header seems to be working, but nothing else. So let's look at this a little more closely. Let's look at the binding syntax that we're using here. Oh, I see the problem here. The code that I pasted in references item dot. We don't need that. There we go. And you can even see when I made that change, it came in on the preview. Very cool. Okay, so admittedly, this is just lorem ipsum, but it seems to work. There is a problem though, in that the text bleeds off to the bottom, and I can't move it. What I really would want to do is be able to scroll down to read the entire paragraph there. So that's an easy change to make. What I'm going to do is I'm going to wrap a scroll viewer around pretty much this entire layout route. So scroll viewer, and the good news is that that's really all you have to do to make this work, like so. Let's run it again. And now I'm able to scroll down and read all the text. Very nice. All right. Now there are some issues, like that application name is really bugging me. Where is it getting application name from? Let's see that, because it seems to be coming from the same spot. I suspect it's coming from the strings folder. And if I double click the resources RESW, you can see here that header text, hub header, all those things, some of them are being pulled from this. So if we change this to I love cupcakes, let's see if that changes it everywhere. No, didn't change it there in the hub header. Let's stop. I think we'll need to change this one more time. I love cupcakes. All right, now let's run it. Ah, there we go. There we go. So let's click on the one. Yep, I love cupcakes shows there. Let's go over to the videos, click on one of these items. Oh, it's not pulling it there. My application. All right, so I think it's just the way that default item page.zaml, where is it pulling its text from? All right, I think I can just change it by going here and just changing cupcakes. Let's try it again. All right, works there, and works there. Great. Okay, that's all I needed to do. Okay. Let's see. You know what I could do to make a small improvement here is to put some space in between each of these thumbnails. I don't like the fact that they're running together there. So that'll be the last improvement that I make here. Everything else seems to be running the way that I'd hoped. And so we're gonna have to make a fundamental change to the let's look at the hub page.zaml. Let's take a look at section 3 here. Let's look at this standard triple line template. Go to its definition at the top of the page. And I think that I can just add a margin here. So we'll say 0 and 0 and 0 and 20. Yep, and that added a nice spacing in between each of the grids that represent each item of data in this data template. Okay? And I think that's all the adjustments that I'm going to make to this. Hopefully you're able to follow along. This was a long video, but it was important for you to see that how we were able to take what we've done here, our work with the Hub app template, and turn it into something more aesthetically pleasing, or at least more customized to our specific app style. So we're going to continue on and continue learning some more about the Hub app template, and maybe extending its functionality a little bit further in the next lesson. So we'll see you there. Thank you.